Hi guys, let's take a look at a few more examples and how you can use the fundamental identities to simplify expressions. For our first example, we have to simplify sine squared of x times secant of x minus secant of x. The first thing that I would note on this one is maybe just a common strategy that you guys can use. And I would say factor out anything in common. So look back at the expression. What do you see that is in common between the first and the subtracted part? What is that? Secant of x. That means that we can factor out secant of x, and we get secant of x times sine squared of x minus 1 in the parentheses. Next, I want to replace this sine squared of x minus 1 with what it is equivalent from. One of the strategies you wrote down in your flip book yesterday was a Pythagorean identity. Whenever you see squares and ones, think Pythagorean identities. So let's look at an identity that you can actually use for that. Well, we know that cosine of squared x plus the sine squared of x adds up to 1. Okay? I need sine squared of x minus 1, so I'm going to rearrange this original expression to get what is sine squared of x minus 1 going to equal. Well, I transferred this 1 to the left-hand side, and now I have minus 1. I need to move the cosine squared of x to the right-hand side, and that will come out as negative cosine squared of x. You can also think of it as you need to subtract the cosine squared of x from both sides. But now I can see that the sine squared of x minus 1 is equal to the negative cosine squared of x. So when we're trying to simplify our expression, we can replace the sine squared of x minus 1 with negative cosine squared of x. Now we're multiplying a positive and a negative, so to simplify, we can put the negative sign up front. We know that secant of x is really equal to 1 over cosine of x. And then we need to multiply by cosine squared of x. You can easily see that that simplifies to negative cosine of x. Let's take a look at the next example.